All right, so we are going to begin our lesson, and today we are going to learn about separable differential equations. And it'll make sense why they're called separable differential equations, because we have a differential equation here, and if we separate them, we can find our, it's just called a general, some kind of general solution or general equation from our derivative here. So it's kind of neat to follow these steps. Right now we have variables on both sides, and to separate these variables, we kind of want to just move our expression around. So if I multiply y on both sides here, and then multiply, that would give me over here y dy, and then I can multiply both sides by dx, and then that separates our variables. So on this expression, we would have y dy equals 2x dx. And hopefully you recognize this notation here, and we can get rid of our derivatives by doing the opposite, which is an integral. So I can apply the integral to both sides of the equation. And now the integral of y with respect to y is just add 1 to the power, divide by the new power. And we would have plus a constant here. And then on this side, we would add 1 to the power, divide by the new power, which would give us just x squared. And we'd also have plus a constant, but we already have a constant here, so we don't need to write it twice. Now, if we're going to solve this differential equation, we need to isolate our independent variable. So we need to get y squared by itself. So I'll go ahead and move my constant over. So I have 1/2 y squared equals x squared, and notice how I still have plus c. We could write minus c. This constant can be a positive or a negative. It doesn't really matter if the value holds true to be a positive or negative. I'm just going to keep it as a plus c because that's what we typically see. Get rid of my 2 here, or 1/2, by multiplying by the reciprocal on both sides. And we're going to kind of follow up with that same thing as if I have 2x squared plus 2c, well, that's really still just double my constant, so I could just still call that c, because that constant still represents some number. Whether it's a negative number or that number is doubled, it's just some constant. And now to isolate my y variable, I would have plus or minus the square root of 2x squared plus c. And there is my general solution to the differential equation. So let's try one more. Again, I'm going to encourage you to really try to be interactive with these videos and press pause, replay, try to solve some of them yourselves, and then come back and watch them again if you need to. So here we have the differential equation dy dx equals x times 1 plus y. We need to separate our variables, always being our first step. So I'm going to go ahead and multiply dx on this side and then divide by 1 plus y. So I would have 1 over 1 plus y dy equals x dx. And then to undo or get rid of those differentials, I can just take the integral, the opposite of that, and then just try to start finding the integral. So the integral of this, well, we just talked about this. This is just the natural log of the absolute value of 1 plus y. And this is just add 1 to the power, divide by the new power, 1/2 x squared plus constant. You'll kind of see now that I no longer have my plus c on the left-hand side. Like I said before, it doesn't matter if it goes on the left or the right. To save myself a step, I'm going to put it on the right-hand side because I know I need to isolate my y variable. So it just saves me from minusing and then trying to remember to keep that a positive c or not. I guess it doesn't really necessarily matter. You'll see it as plus c more often. Now, to get rid of natural log, we can go back to our laws of logs, and I can apply the same operation to both of these, and I can take both of these and make them to the power of e, because I know that e and natural log are inverses of each other, this would leave me with just the absolute value of 1 plus y equals e to the 1/2 x squared plus a constant. This leaves us again with thinking about what this all means, because it looks quite messy here, but we know if we had just, e to the x times e, I don't know, some constant, then what we do when we have the same base is we just add our exponents. Well, we can kind of work backwards here and undo what we just did, and we could say this is the same as 1 plus y e to the 1/2 x squared times e to a constant, because we just add those powers. And now we know that this right here, this again is just some constant, and we could call that constant something other than c, because it has a different value. We could call it, and you can just make up another letter, we'll just call it a. These two are the same thing. I'll maybe draw in a little arrow there. So we're going to say that e to the c is represented now by my constant a, and then I have e to the 1/2 x squared. So now I have these two expressions which are equivalent, and 1 plus y. Well, to get rid of this absolute value, we know the absolute value of x, if we had it equal to 3, that would just give us a plus or minus 3. We can kind of do the same thing here. We can say 1 plus y is going to give us a plus or minus a e to the 1/2 x squared. And we said this before, but if we have a positive or negative here, it's a function. It can only have one output. So whether that a value is positive or negative, it doesn't really matter. It's still just a constant. So we have 1 plus y is equal to a e to the 1/2 x squared. And we're almost done. We just need to isolate our y value, and we get a to the e 1/2 x squared minus 1. And that is our general solution here.